few important relations. If H plus concentration is equal to 10 to the power of minus x, then what about pH? pH is equal to x, right? If H plus concentration is equal to 10 to the power of minus y into x, or x into 10 to the power of minus y, then pH is equal to, first what is present in powers? Y. So y, first write the term which is present in powers, y minus log x, y minus log x. See, let us take one example. If H plus concentration is equal to 10 to the power of minus 3, then pH is equal to 3. Like that. If H plus concentration is equal to some 4 into 10 power minus 3, then tell me pH is equal to 3 minus log 4. 3 minus log 4. What is log 4 value? Log 4 value 0.6020, so you can consider it as a 0.67. Okay. Next, what is ionic product of water? What is ionic product of water? What is the symbol for ionic product? Ionic product symbol is Kw. What is the definition of ionic product? Definition of ionic product. It is the product of concentration of H plus and OH minus present in water at 25 degrees centigrade. Let us take water. In water, H plus and OH minus ions are present. Their product only called as ionic product. H plus concentration into OH minus concentration. Product of H plus concentration and OH minus concentration is called as ionic product of water. And what is its value? 10 to the power of minus 14 units are mole by liter whole square at a 25 degrees centigrade. And one very important point, can I use this relation for aqueous solutions? Actually, this is for water. Ionic product of water I mentioned. Means this relation is purely used for water, no problem. Can I use for aqueous solutions? Yes, we can use for aqueous solutions also. Not only for water, we can use this expression for aqueous solutions also. H plus into OH minus is equal to 10 to the power of minus 14 mole per liter whole square. So Kw value can be taken as 10 to the power of minus 14 mole by liter whole square. H plus into OH minus value also same, Kw value also same, 10 to the power of minus 14 only. Here at which temperature? 25 degrees centigrade temperature. Now you tell me, according to chemical equilibrium, equilibrium constant depends on what? The one and only factor which affects the equilibrium constant is temperature. Similarly, Kw also depends on the temperature. At 25, this is the value. You tell me at 50 degree, what may be the value? Kw value, see, 10 power minus 18, 10 power minus 7. As temperature increases, Kw value increases. At 25, this will be the value, A and B. At 50 degree, what is the answer? A.
O increases.
A or B? B is the answer. B value is more than 10 power minus 14 in terms of minus. As temperature increases, Kw increases. You increase the temperature, so 10 power minus 7 is greater than 10 power minus 14. Clear? Right, next up. I given acid dissociation constant introduction also yesterday. Ka is acid dissociation constant. Kb is Ka into Kb is equal to Kw. Ka into Kb is equal to 10 to the power of minus 14. I given this relation also in yesterday's class. In May 3rd, one question came based on this. Simple question only, but most of the students didn't use this. So they did wrong. They didn't use this relation. So question clear. So yesterday's class is just like introduction type. Now let us start continuation. I given basic level questions also to calculate pH value in the last class. Now let us do some other questions. Find the pH of one or two questions on the molarity. Okay, find the pH of 0.01 normal HCl solution of volume 50 ml when it is diluted to 100 ml. Just one or two model questions, and the molarity normality. Yes. Find the pH of 0.01 normal HCl solution of volume 50 ml when it is diluted to 100 ml. See, I'll explain this with the help of the diagrams. I have 50 ml. What is its volume? 50 ml. HCl solution. What is its normality? N1 is equal to 0.01. What I am doing? Diluted to 100 ml means I am adding 50 ml water. 50 ml water is adding. 50 ml water is adding. Then what about final molarity? Final normality, you have to calculate it. N2 question mark and V2. What is V2? 100, because already 50 ml is there, you are adding 50 ml. 50 plus 50, 100. Calculate final normality. What is the formula? Online students, which formula we use? Dilution principle formula. Pritika? Yes, N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. N1 is 0.01, 50. N2 you have to calculate, this is 100. Okay, after simplification, what we will get? 52 times 2 will be present here. So by 2, 0.01 by 2. 2 remains here. Send it to this side, 0.01 by 2. Okay? 0.01, 1 by 2 means 0.5. So finally what you will get? 0.005. 0.005. N2 final normality concentration is 0.005. Nothing but 5 into 10 to the power of minus 3. This is nothing but H plus concentration. When normality data is given, you can take a final normality only, final H plus concentration. When normality data is given to you, remember the trick. You will get final normality now. Take that as H plus ions concentration when normality data are given. When question is given in normality, you will get final normality. Take that as H plus concentration. So you got H plus concentration. If H plus concentration is equal to 5 into 10 power minus 3, then what about pH value? Format, pH format. Power, first write power 3 minus log 5. Log 5 value 0.7, that is equal to 2. Dilution principle. In ionic equilibrium, probability is there to get the question which depends on the stoichiometry. Molarity, normality, stoichiometry background only, na? Normality, molarity background, right? Right, next question, another model. Find the pH of 0.48 grams of H2SO4 present in 500 ml solution. Find the pH of 0.48 grams of sulfuric acid present in 500 ml solution. This is also based on the stoichiometry only. Find normality. Consider it as H plus ion concentration. Normality is equal to weight by gram equivalent weight into 1000 by volume in ml. Right? Normality nothing but H plus ion concentration. Weight how much given to you? 0.48 divided by what is equivalent weight of sulfuric acid? Online students. What is equivalent weight of sulfuric acid? How to find equivalent weight? Equivalent weight for acids is equal to molecular weight by basicity. Molecular weight is 98 by basicity is 2. 49 to 1000 by volume is 500. See, approximation 48 can be taken as 49, nothing will happen, clear? When data came like this, you can take approximation, nothing will happen, cancel these two. Here point is there now, so you have to write 1 by 100 into this value 2 times. Nothing but 2 into 10 to the power minus 2. 2 into 10 to the power minus 2. Actually here if 0.49 come, then you can cut easily. 48 and 48 nothing will happen. You can take approximation. Okay, there is no drastic changes in the values. Final value 2 into 10 power minus 2. Then what about pH value? pH value. pH is equal to, see, if H plus concentration is some number into 10 power minus 2, first write the power number, what is present in the powers 2. 2 minus log 2. 2 minus log 2. Log 2 value 0.3010. 1.7 is the answer. How you got 2? First you said P. Now keep adding new topic. pH of weak acids. pH of weak acids. Before that, all of you note down the list of weak acids, weak bases. This is very important. Weak acids list, weak bases list. This is useful for the salt hydrolysis, useful for the buffer solutions. Okay. Strong acid, weak acid, everyone should have this. No? Strong base and a weak base. Everyone knows about strong acids list, I hope. HCl, H2SO4, HNO3, HClO4, perchloric acid. Weak acids list. Acetic acid, H3PO4, HCl, HNO2, H3CO2, all are very important. Organic acids like benzoic acid, formic acid. Organic acids are weak acids. Organic acids are considered as weak acids. If you do not have idea about the strong weak acids list, weak bases list, you may face difficulty in buffer solutions and in salt hydrolysis concept. Next, very important concepts are going to start. Now onwards, concepts are very important. Question coming area also. Strong bases. Sodium hydroxide, potassium hydroxide and cesium hydroxide. Last element in the first year group, lithium, sodium, potassium, rubidium, cesium. Second year group, beryllium, magnesium, strontium, barium. These are the strong bases. NaOH, KOH is easy, everyone can find. Cesium hydroxide, barium hydroxide also strong because it is more bond length, their size is more, so they lose OH minus easily. Weak bases, most important weak base, ammonium hydroxide. Actually this only will come frequently, first one. Try to remember these also. But first one is mandatory. First one is very important. So this is just a memory based concept only, but play very important. Plays very important role in the numericals. Salt hydrolysis, buffer concepts. Now, what is our main heading? pH of weak acids. pH of weak acids. Identifying the formula is very important. Identifying the formula. You will get different questions, but for which question, which formula we have to take, that is very important. When you get a weak acid, then only use the formula. Weak acid means any one of this. Right, start. pH of weak acids. Weak acids, what are weak acids? The acids which undergo partial dissociation, incomplete dissociation are called weak acids. I am taking acetic acid. Acetic acid is the best example. CH3CO negative and the H+. Let us consider initial concentration is C. It is 0, 0 initially before dissociation. Out of C, some C alpha part is undergoing dissociation. Out of C concentration, some C alpha concentration is undergoing dissociation. So this is C alpha, this is also C alpha, right? You don't need to learn this method, how I am deriving, but what you have to remember, I will tell you. Once look at this. Whenever you observe weak acid, if you remember 3 formulas, that is enough. That is enough. Okay, if you remember 3 formulas, that is enough. I will give the model question also. See, first H plus concentration, first important formula, H plus concentration is equal to C alpha, where C is the concentration of the weak acid, alpha is the degree of dissociation. I will give the terms, first formula. Next, second one, acid dissociation constant Ka is equal to C alpha square, second formula. And third one, pH is equal to, any idea?
Minus 1C.
1 by 2 pKa minus log C. 1 by 2 pKa minus log C. You no need to learn about the derivation part. Just you remember these 3 formulas. Okay. H plus concentration C alpha, acid dissociation constant C alpha square. In second year also we use this relation, electrochemistry. We did question also, incoming series. And pH 1 by 2 pKa minus log C. So whenever you observe weak acid, use this relation to find pH. You have 4 different formulas, you may get confusion. So practice is very important. I will give you one question to you. Have you copied? Online students. See the question. Find the pH of 0.01 molar acetic acid with the acid dissociation constant acid dissociation constant of acetic acid is 10 power minus 2. Acid dissociation constant means which data is given to you? Kr, pKa, which is given to you? Ka only given, okay? First of all, write the data. Concentration of the acid is 0.01. 0.01. Right, Ka value, Ka is equal to 10 to the power of minus 4. Then what about pKa value? What about pKa value? If Ka is 10 power minus 4, then pKa is, online students, pKa is 4. Because pKa is equal to, what is the relation? Minus log Ka. Substitute Ka value if you want a solution. Minus log Ka value is 10 power minus 4. Minus will come front. Minus 4 into minus 1 plus log 10 value 1. So 4 into 1, 1. Minus into minus plus, you will get like this. 4 log 10. Log 10 value 1, that is equal to 4. Now what is the formula? What is the formula? pH is equal to half pKa minus log C. Direct formula substitution. Tell me. 1 by 2 into pKa value. pKa value 4 minus log concentration 0.01. Can we write this as 10 power minus 2? So 10 power minus 2. 1 by 2 into 4. Bring minus to front. Already here minus is there. No? Minus into minus. Lesser. 2 log 10. Log 10 value 1. So 1 by 2 into 4 plus 2. Log 10 value 1. 4 plus 2 6. 6 into 1 by 2. This is applicable for all weak acids, not only for acetic acid. If you get acetic acid, then you can identify easily. Instead of acetic acid, I can take a H3PO4, I can take HCl, I can take HNO2, I can take benzoic acid also. All are weak acids. Okay? Right. Now, another heading. pH of weak bases. pH of weak bases. Similar to pH of weak acids. Here first I am giving the formula directly. OH minus concentration is equal to C alpha. Kb is equal to C alpha square. Alpha is the degree of dissociation. Third one. What is the formula for pH? 1 by 2 pKa minus log C. Here pOH is equal to 1 by 2 pKb minus log C. Right? So after getting pOH, you know how to find pH value. What is the relation between pH and pOH? pH plus pOH is equal to 14. First you will get a pOH value because base will be given to you. Okay? Right. This is about pH of weak acids and weak bases formula. Right? Next, keep heading. I given types of acids, types of bases, weak acid, weak base. Right. Next, very important topic, keep heading, salt hydrolysis. Salt hydrolysis. Salt hydrolysis. Once look at this, all of you. This is cation or anion? Cation or anion? Anion. This is cation. Addition of water to anion or addition of water to cation of a salt to get acidic solution or basic solution. Acidic solution. Here you will get acidic solution. When you add water to negative ion, you will get a acidic solution. Basic solution. Here which will add, sorry, reverse I wrote, just a second. Basic solution, here acidic solution. See the definition. I'll tell you why we are getting acidic, why we are getting basic. Very easy, right? See, addition of water to cation or anion of a salt to get acidic solution or basic solution, vice versa, is called as salt hydrolysis. Okay. Very important point. Which type of ion undergo hydrolysis? Can we add water to all types of anions? Can we add water to all types of cations? No. Only strong ions, strong cation, strong anion only undergo hydrolysis. But how to know which is strong and which is weak? How to know? Only strong cation undergo hydrolysis, strong anion undergo hydrolysis. But how to know which is strong, which is weak? Let us write the point. One simple definition for the salt hydrolysis. Addition of water to anion or cation of a salt to get basic or acidic solution is called as salt hydrolysis. Salt hydrolysis, right? Very important point. Only strong anion cation undergo hydrolysis. Only strong cation, only strong anion undergo hydrolysis. Some salts do not undergo hydrolysis. The reason is this one. Let us see. Anion. Tell me. See all of you. Anion comes from weak acid. Weak acid is strong. Weak acid is strong. Anion which comes from weak acid is strong. For example, acetic acid CH3COOH. Dissociate this CH3COO negative and H plus. This anion is coming from weak acid. Very simple. If anion comes from the weak acid, that will be the strong. Given one sentence here, anion comes from the weak acid is the strong. Okay. Similarly, HCN is weak acid or not? Weak acid only, na? CN minus is strong because it is coming from weak acid. I given weak acids list. Similarly, cation comes from the weak base is strong. One see weak bases. cation comes from weak base is strong. Example, ammonium hydroxide is the weak base. NH4 plus. It is coming from the weak base, so it is a strong. Similarly, aluminum hydroxide is the weak base. Al plus 3 is the strong. Zinc hydroxide is weak, so Zn plus 2 is strong. The one which comes from weak is strong, simple. Now, I given salts list. I said to learn about salt list, acids list, bases list. Right. Once go back to the table. With the help of this table, we can classify the salts into 4 categories. In that 4 category, you have 3 formulas. Most important, already we completed one formula, pH of weak acid, 1/2 pKa minus logs. 3 more formulas are there. We cannot expect which question will come, but one question will come. Right. See, when you mix a strong acid and a strong base, means if you mix HCl and NaOH, what you will get? Tell me, which salt you will get? Salt formula. You are mixing HCl and NaOH. You are mixing strong acid and strong base. What you will get? What you will get? NaCl. NaCl is formed. NaCl is formed and H and OH, water will be formed. Water will be formed. Clear? From acid and base, remove water molecule, write the formula. From acid and base, remove water molecule, write the formula. This is called as salt of strong acid and strong base. So you tell me what is NaCl category, which type of salt it is? Salt of strong acid and strong base. Salt of strong acid and strong base. Clear? NaCl is the salt of strong acid and strong base. Now let us see the types of salts. Based on the types of acids and bases, we can classify the salts into several categories. This idea is very, very important. See, types of salts. Types of salts. Roman number 1, salt of weak acid plus strong base. Salt of weak acid plus strong base. Identifying the salt, type of salt is very, very important. Then only you can choose the correct formula, appropriate formula. Salt of weak acid plus strong base. I will give you one frequently coming example. Acetic acid, NaOH. Acetic acid and NaOH. Then how to write the salt formula? Tell me. Salt formula. CH3COO Na. Remove water and join remaining part. Remove water from this. How to remove the water? H2O will be eliminated. Remaining part is CH3COONA. So CH3COONA is which category salt? Salt of weak acid plus a strong base. So when you get this salt, you have to use one particular formula. Separate formula is there for it. Clear? If you select wrong formula, you will get wrong answer. Now can you give some other examples? Can you frame some other example? I given one frequently coming example, sodium acetate. Can you frame another example? Anybody? Can you give some more examples? Yeah, tell me. That is common only. Now take different one because both are similar only. Can I use this one? Tell me. Na3PO4. Na3PO4. Can I take this or not? Tell me. Na3PO4 is the type of which salt? Salt of weak acid. H3PO4 is the weak acid. NaOH is the strong base. Right. Another example. Can I take KCN? KCN. HCN is the weak acid. Potassium hydroxide is the strong. Okay. You can frame already given examples list. Okay, you can take weak acid and strong base. Similarly, can I use this one? Na2CO3. Yes, weak acid. H2CO3 is the weak acid. But frequently this example will come. Which example? Sodium acetate will come. First category salt is okay for you, everybody? Huh? After seeing the salt, you have to identify under which category it will come. Salt of weak acid plus strong base. Second is salt, tell me anybody. Second category. Weak acid, strong base. Next, strong acid, weak base. Next, Roman number 2. Salt of strong acid plus weak base. This is also important. Salt of strong acid and weak base. Take one strong acid, HCl. Take one weak base, ammonium hydroxide. Remove water. H2O minus H2O. Remaining part NH4Cl plus H2O. So NH4Cl is the salt of strong acid plus weak base. Identifying the salt is very, very important. If you identify the salt, then you can choose correct formula, right? Some more examples. One is NH4Cl, frequently coming example. Can I take AlCl3? Aluminium hydroxide, weak. HCl is strong. Can I take this one? Aluminium sulfate, Al2SO4. H2SO4 is the strong, right? But this is only important example. Just if possible, remember, otherwise leave it. If you learn the list, then you can frame, no problem. Alright, salt of strong acid plus weak base also completed. Next category. Both are weak. Keep adding. Salt of weak acid plus weak base. Salt of both are weak. Weak acid plus weak base. This is also very important combination. Both are weak. Give one example. Ritika. Acetic acid and ammonium hydroxide. Remove water from this. Remove water. Sorry, just a second. Then what we will get? CH3, COO, NH4. Very important. Ammonium acetate. Ammonium acetate is the type of salt of weak acid plus weak base. Ammonium acetate. Salt of weak acid plus weak base. Can you frame another example? Can you give another example? Both are weak. Other than this example. NH4CN. HCN is weak. Ammonium hydroxide is also weak. NH4CN. Right, next category. Salt of strong acid. Salt of strong acid plus strong base. Both are strong. Write examples directly. NaCl. NaCl will come from NaOH and HCl. Both are strong. Why this data is important, I will tell you. This do not undergo hydrolysis. Which of the following salt do not undergo hydrolysis? Answer is salt of strong acid plus strong base. Why? Can you guess the reason? I'll tell you the reason also during that concept. Clear? That's why idea is very important. K2SO4 is the type of salt of strong acid and strong base only. KOH and sulfuric acid both are strong. Now let us start. First one, hydrolysis of salt of weak acid plus strong base or strong acid plus weak base, vice versa. And let us derive the formula for the numerical. Very, very, very important. See all of you. Keep reading first one. So I given the types of salts. Hydrolysis of salt of weak acid plus a strong base. Hydrolysis of salt of weak acid plus strong base. I already given example. Weak acid plus strong base. Say example. Example for this salt is CH3COONA, sodium acetate. See the procedure, all of you. How I am doing. CH3COONA. How it will dissociate? It dissociates into CH3COO negative and Na positive. Which is strong here? Which is strong? What I said, the one which comes from the weak is strong. The one which comes from the weak is strong. The one which comes from the strong is weak. Sodium hydroxide is strong base or weak base? Tell me. Very simple. Sodium hydroxide is strong base or weak base? Strong base. So sodium plus is weak. Sodium hydroxide is strong base. So sodium plus is weak. What about acetic acid? Weak. Acetic acid is weak. Acetate ion is strong because it is coming from the weak. So first of all you should write strong and weak. Don't touch weak ion. Weak ion. Leave it. Now take the strong, add water for this only because I mentioned the condition. Only strong ions undergo hydrolysis. You are adding water to acetate ion only because this is the strong. Right? CH3COO negative and H2O. In water, H plus ions are present or not? How it will dissociate? Water dissociates into H plus and OH minus. OH minus. Water dissociates into H plus and OH minus. That H plus attaches to acetate ions because this is negative. So H plus will attach to form. Tell me, acetic acid CH3COOH. COOH. Now you tell me, free OH minus ions are present or not? Free OH minus ions. So due to liberation of free OH minus ions, the resulting solution is basic in nature. So very, very important. What is the nature of a solution of sodium acetate? Basic nature. Means when you add sodium acetate to water, take a beaker, pour some water and put sodium acetate in it and dissolve. You will get which solution? Basic solution, because free OH minus ions are generating. Take water, add sodium acetate and dissolve it, stir it, you will get basic solution because free OH minus ions are generating. Don't think that, sir, acetic acid is formed, nature of the solution is acidic. That is wrong. If free H plus ions are present, then acidic nature. If free OH minus ions are present, then basic nature. Very, very important. Mention that point. Theoretically, that is very important. So, nature of the solution is basic. Since free OH minus ions are present, nature of solution is basic in nature. So you tell me, for basic solutions pH is less than 7 or greater than 7. For basic solutions pH is greater than 7. Greater than 7 means 7 plus something or 7 minus something. 7 plus something. So formula start like this. pH is equal to 7 plus. 7 plus. You will get confusion. 7 plus 7 minus. Very easy. Free OH minus ions are there. So basic. So greater than 7. So 7 plus. Okay. 7 plus. Tell me. 7 plus 1 by 2. Which is weak here? Which is weak here? Which is weak? In this case, weak acid. So take that dissociation only. Plus log C. Here also you may get confusion. Sometimes you will try to take pKb, which is weak in the given mixture. So take that dissociation constant. Okay, put in the box. Very important. When we use this formula, when you get sodium acetate. In this, what is C? What is C? C is what? Concentration of salt, sodium acetate. Ka will be given to you. Ka is dissociation constant of acetic acid. Dissociation constant of acetic acid. Identifying the formula, choosing the formula is very, very important. 7 plus 1 by 2 pKa plus log C. First formula is what is before that what I given for weak acids, what is the formula? Now you learn to two formulas, right? For weak acid what I given? pH is equal to half pKa minus log C. This is second formula. 7 plus 1 by 2 pKa plus log C. When we use this formula, when you get the data of CH3COONA or salt similar to this. Next, keep it in. Hydrolysis of salt of weak acid plus strong base is our second category. What is second category? Strong acid plus a weak base. Strong acid plus weak base. Shall I go to next page? Okay. Roman number 2. Hydrolysis of salt of strong acid plus a weak base. Example for this, ammonium chloride. It is formed by HCl and NH4OH, strong acid and weak base. Dissociate this. NH4Cl dissociates into NH4 positive and Cl negative, which is stronger. Cl minus is strong. No, Cl minus comes from HCl. HCl is a strong acid, that is weak. This is strong. NH4, ammonium cation is the strong. Cl minus is weak, very easy. Cl minus comes from strong acid HCl. The one which comes from the strong is weak. So NH4 plus is the strong. So take that only and add water to it. NH4 plus and water. Right. In water, H plus and OH minus ions are present. So towards NH4 plus OH minus ion will go and H plus will be liberated. Free H plus. And here you will get NH4 OH. Right. In the solution, free H plus ions are generating. So nature of the solution is acidic. Right, directly. The nature of solution is acidic. Since free H plus ions are generated. So pH value, guess pH value, 7 minus something or 7 plus something. 7 minus, because acidic solution pH is less than 7. So next, third formula, pH is equal to 7 minus 1 by 2, which is weak here, phase. So take pKb plus log C. So when NH4Cl is given to you, or salt similar to NH4Cl is given to you, use this formula. Next, third category, weak acid plus weak base. Can you guess the nature of the solution for third category? For third category, what is the nature of the solution? Acidic or basic? On what basis we can predict? Roman number 3. Hydrolysis of salt of weak acid plus weak base. Example is CH3, COO, NH4. You tell me which is strong here. Online students, which is strong? Which is strong? Both are strong. Both are strong. Then how to decide the nature of the solution? If one is strong, we take that only and we add water to that and we will get free H plus or OH minus ions. In this case, based on the Ka, Kb data, we will predict. Very, very important theoretical question. Okay. See, if Ka is greater than Kb, nature of solution is acidic. Nature of solution is acidic. If Kb is greater than Ka, nature of solution is basic. Okay. Based on Ka, Kb data, we will predict the nature of the solution. Right? Now, formula pH is equal to 7 plus 1 by 2, very important, pKa minus pKb. When you get salt of weak acid and weak base, use this formula 7 plus 1 by 2 pKa minus pKb. We'll do the numericals on different formulas. Okay, learn before that. What is last category? Salt of strong acid and strong base. Keep heading. Salt of strong acid and strong base. Salt of strong acid and strong base. Salt of Ska plus Sb. Both are strong. Both are strong. Example, NaCl. NaCl dissociates into Na plus and Cl. Which is strong, which is weak, or both are weak? Both are weak. Na plus comes from sodium hydroxide. Cl minus comes from HCl. Both are weak. So, do not undergo hydrolysis. Which do not undergo? NaCl do not undergo hydrolysis. So, there is no form. There is no form. NaCl, K2SO4, these salts do not undergo hydrolysis. Have you completed? Online students? Note down this question, find the pH of 0.1 molar CH3COO. The Ka value of acetic acid is 10 power minus 6. Selection of formula is important. Which salt is given to you? Salt of weak acid plus strong base. First of all, write the data. Concentration is 0.1, that is equal to 10 to the power of minus 1. Ka value is 10 to the power of minus 6. Then what about pKa? pKa is equal to 6. Formula, this is salt of weak acid plus a strong base. So pH is equal to, tell me, 7 plus something or 7 minus something? 7 plus 1 by 2 pKa plus log C. pH is equal to 7 plus 1 by 2 pKa 6 plus log C value 10 power minus 1. 10 power minus 1. So pH 7 plus 1 by 2 6, tell me, minus 1 will come front, right? So minus log 10. So pH is equal to 7 plus 1 by 2. 6 minus log 10 value 1. 6 minus 1, 5. Into 5. 1 by 2 into 5. 1 by 2 into 5 means how much? 2.5. 7 plus 2.5. That is equal to 9.5. Why we are getting 7 plus something? Because basic solution. Nature of the solution is basic. So pH value 9.5. This is one model question. Similarly, other models also we can do like this. Okay. Now do this question, another one. Have you completed previous question? Online students, are you following? All of you? Next question. Find the pH of if Ka is equal to 10 to the power of minus 5 and Kb is equal to 10 to the power of minus 5. What is the answer? Online students. So no one is responding. What happened? Meenakshi, Adiva, Unnara, Meeriddar. Are you there? See, Ka is given, right? What about pKa? 5. What is pKb? 5. Both are 5. When both are same, no need to calculate. You can say directly. pH is equal to, this is solution. Yes. 7 plus 1 by 2 pKa minus pKb. pH is equal to 7 plus 1 by 2 5 minus 5, 0. 0 into 1 by 2, 0. That is equal to 7. Right? This is one subtopic. Okay. Tomorrow, another topic. We will do the numericals also. See. Tomorrow, buffer solutions, the solubility product. Buffers and solubility product. Okay.